All right, so we want to create a brand new feature of creating a RESTful controller. So to do that, we'll create a new branch. So we should never work on the master branch. Instead, we work on a feature branch every time that we want to add a new feature. So we're going to say git. So you can either create the branch itself, git branch, whatever, and then check it out, or you can do a, yes. Yeah, no. For the first one, yes, you could do just one. Yep. In the next assignment, you'll be asked to do several and create a PR since you're not going to be in a team just yet. You'll be asked to do create a pull request and ask the TAs to merge it for you, right? And so you just to get the just to get the feeling of having someone look at your code, right? All right, so before we created the branch using git branch and whatnot. Or you can also do it by right away doing a checkout -b and then the name branch. This creates the branch and checks it out at the same time. Okay, that's one thing about Git, that they have like 2, 3, 4, 5 different ways of doing the same thing, and it's sometimes fairly confusing. So anyway, this is the hello controller. It's hello controller branch. All right, so now we're in the hello controller branch. So git branch, we are in the hello control branch. Okay, so now that we're in there, let's import our project and start coding. All right, so let's code a couple things in there. So let's import our brand new project that we created. It's a Maven project because we got a POM file in there. Let's browse. It's under Januzzi. CS 4500 and section 3, and there's our project. We're going to open that up, and I'm going to say finish, and there it is, right there. So a couple things just to note. When we created the default project, it creates this demo application, which is worth noting. This is the entry point to the application. Right? Notice they've got a main file. And we're not going to touch this. The only point that I want to make here is that the controls that we're going to be creating, any data models, any access to the database, any of those that are going to come up a little later in the semester, we're going to create them all off of this package over here. Okay? So this is going to be our root package. Under that package, we can create a whole bunch of other packages. Right? We can create code outside of this package, but it would be additional configuration that I don't want to get into. Right? It just makes it so much easier if you work under this particular package. Make sense? Right? I don't want to get into a whole bunch of other configuration. If you are under that package, a lot of magic happens. Right? So let's stay within the magic. Let's create a class here, and we'll create our hello controller. Right? And under that root package, I'm going to create all my controllers are going to go under controllers. Yes? Right? And there's my Java class. There's nothing special about this class other than that we're going to decorate it. We're going to say that this is a REST controller. A REST controller. This is called a decorator, and it's a style of programming that has become very, very popular in most frameworks. It's a style called aspect-oriented programming, where just like this object-oriented programming, there's a component-oriented programming, right? Each one advocating certain ways of building things, right? And all sorts of different abstractions and ways to hide a lot of the complexity. This is aspect-oriented. What it allows you to do is decorate your class with lots of behaviors that would not be available otherwise. The behavior that this decorator allows you to have is to make this class now available to be accessed through the internet, right? By a URL. Allows you to map it to some URL on the server and then refer to this class and anything that's inside of this class. Make sense? Right, that's what the behavior that allows you to do, that adds the REST controller. So for instance, any function or any any method that I add here, right? So say hello, return hello world. I can now expose this function to be executable from outside, right? Through a URL invocation, right? Just because I have decorated this class, right? Meaning there's a lot of magic that is being invoked by this decorator. Right? So today we can to map what URL do you want to map it to? You use another decorator called the Get Mapping Decorator. Right? And you can configure it saying, what do you want to map this function to? We're going to map it to API/hello. Meaning that if the server sees this particular URL, right, it's going to map it to this function, it's going to execute it, and it's going to return whatever the function returns. In this case, a string. Everybody good? All right, so let's try it out. Oops. Let's go back here, and we can look at Git Status, meaning what have we done so far? We can add this the work we've done so far. So git add that directory. Oops, I'm sorry. I didn't mean that. Git add, so adds all that. So git status sees that status. It says that, oh, there's this new file that I'm keeping track of, right? I'm not done with it yet, so I'm not going to commit it. I'm not going to commit it just yet. Let's not get overzealous. So let's try it out. Let's compile this. Let's see what it looks like. So we can do Maven clean install. Let's test it first, see if it's doing what it's supposed to do before committing it. It's compiling it, but I see that I have something running on the other tab, so I better not run it again, right? So let's run it from this tab. Let's run it. I just compiled it, and now it's running it. Okay, it ran. We can go back and try it out now. We can say localhost, and API hello returns the hello world, that string that it's returning. Make sense? All right. Again, that's a really tiny skill that you learn in this particular assignment. Is not specific to software engineering, but it'll be relevant as we progress throughout the semester. Right, this is one of the many skills that you'll need going forward. How to expose anything. Let's now that we know that we've tested it and that it works, we can go back and actually commit it because we know that we have achieved one particular feature. Right. So let's see, git status, git log, git diff. Okay, we haven't committed anything. So we'll commit this, and we'll say added. Hello world. Hello world controller. Right. Again, your work, should be small enough that you should be able to say this. It's just in a few words. Right. If you find yourself, using more than one sentence, perhaps your commit is way too big. Okay. All right. So we've committed it. Let's keep going. Let's now add another feature, another behavior here. Maybe we like to be a little more, something more interesting. Instead of just returning a plain old string, perhaps we want to work with some model, maybe some user or something that might be mapped to some table in the database. Let's like for instance a user. And since this is going to be a class that holds data. Typically, we refer to these as models, right? That captures features or attributes about a particular type of data, right? So we're going to put this under dot models, right? And under models, let's create a couple of things here. There may be private string, if I can type username, and this is private string password, and maybe private string first name. And private string last name. So follow good software engineering practices. Make all the attributes private, and make them accessible through setters and getters, through public setters and getters, right, which we can generate automatically here. All right, so we have our data model. Right now it's just these 4 fields. And the assignment asks you to create another one, just a hello object. Hello object, But let's. I'm just going to create it, but I'm not going to actually use it. Okay, so I think it asks you to just add a simple string, the message string, right, and then create a setters and getters for that. Okay. All right. So now that we have a data model, perhaps that's a good place to create another commit and see that we have a couple things in there, right? We modify the hello controller. Actually, I didn't mean to do that. We can look at the changes. What did I change? I don't remember. Git diff. Okay. So we have the controller. Looks like the only thing I did is add a new line. Right? I didn't mean to do that. Right? I didn't mean to do that. I had meant to add another function in there, but not yet. Not before I commit the work that I've done for the models. Right? So I'm going to undo my changes to that particular file. So I can do a git checkout, and I can just check out that file again, and it's going to be overridden with what it's already in the repository. So just get it again. Just get that file again. So this says that my only change now is just the models, right? I went back to whatever I had in my controller. All right, so I'm going to add my models. So git add the models, and it says, okay, well there's those two files, and let's commit it. Before we go further into the controller, so we're going to say commit. Oops, sorry, git commit, and this will be added models hello and user. Okay, so we've added that. We can look at the log where we, how we're doing, right, with all the things that we've been doing so far. All right, so now let's go back to the controller and do some work there. In the wait, did I not save that? Uh-oh. Okay, no. Let's go to the controller. There we go. Let's add another public. Maybe we can return a user, get user, and maybe we can instantiate a user. We can say we can load the user, import that user, and then instantiate it. So user Alice, new user, and populate it Alice.set username Alice, and Alice.set first name. And maybe this is Alice, and Alice set last name, and maybe Wonderland. All right, so we created a user, and then we can just return a user. So not only can we just return just a plain old string, we can return an entire object. Right? This could be as complex as you want it. It could be a list of objects or arrays of other things. Right? So it could be fairly complex. So let's see what that looks like. So we're going to map it, and we can say maybe. We can say, get mapping, and we're going to map it to say, /API/user /Alice. Okay, and so let's compile that. We can either compile it from here. I'm going to actually stop this, and we can run it from within the IDE if you prefer, by just running the demo application as a Java application. So that's going to compile, package, and run as well. I stopped this server on my command line. Otherwise, I was probably going to get complaints saying that it was already running. Okay, so it's running. So let's go back. So hello world still works. And if we say API user Alice, returns Alice. Right? So this is a JSON representation, a JavaScript object notation representation of that data. Notice that the attribute names are taken from the same attribute names as in the Java world, right? So there's some conversion between these two layers, right? The middle tier is providing this representation. A more common representation a couple of years ago would have been XML instead of JSON. But since the industry has gone a lot into web development, applications built on the web. And most of the clients are JavaScript clients. This has been a huge shift towards representing it as JSON as opposed to XML. Right? Anyway, there. So there's another skill, right? That it'll be useful a little later in the project, to have clients accessing data from the server. Yes.
So will all
Yes, yes. And there's a naming convention. If you follow Java naming conventions, like this, everything is camel cased, and so on and so forth. There's a whole bunch of naming conventions, which we'll go into detail. Then all these names are also follow that convention.
Right.
Yeah.
So is there any way to control what attributes appear in the object?
Yes, you can override those defaults. You can say, instead of using this name, I want you to use this other name. Or ignore certain aspects, meaning you only want them in the Java world, you don't want them exposed outside. So there's a whole bunch of, yeah, exactly. Yeah, there are JSON decorators. And we'll talk about it quite a bit. For instance, sometimes you have objects that refers to another object, and then that object referring to the previous object, which is fine in Java. But then you get into these infinite loops when you start converting them. So we need to map them and make sure don't get into those infinite loops. So we'll talk about those decorators a little later. Yep. All right, so we added that. We can look at Git status where we are so far. We can look at the diff of where we are so far. We see that we have added that function, and I think it's a good time. It was successful. We tried it. We tested it. We're happy with it, and so we're going to commit it. So commit. Added get user Alice. Right. Excellent. Or we can make it a little later. We'll see that we can be a little more. We can parameterize this a little further. We can say instead of just getting Alice, this could be maybe a parameter, and this might be a username. Yes. And then that parameter could be passed in here as an argument by another decorator. We can say parse from the path, from this path, parse the variable called username. And once you parse it from the path, give it to me as an argument to this function, which these names don't have to match. These have to match. These have to match, but these don't have to match. So I'm going to call this just u. So this might be u, right? And this is somebody, someone else, right? And so this might be a function that perhaps hits a database, right? Does a query, and then it returns the object from the database and returns that to the client. Yes. Yeah, you can provide multiple ones. Could be another argument here.
Okay, so you separate them
with slash. Yeah, it becomes a path. So the client generates a path, right? Or you can provide them as query strings. We'll see that a little later. Why would you do one or the other? Right? Since we're building restful services impose certain constraints on what the syntax is, the appropriate syntax for these paths, right? When you would use one, one way or another, and we'll talk about that a little later. So we can try this out, and notice that this function has been overloaded. This one takes no arguments, whereas this one takes it takes one argument if the path is in so. So if we rerun this, we can restart the server. Yes, no? Okay, we can try it again. So instead of Alice, this could be maybe Bob. So now it returns Bob, somebody, someone else, right? Perhaps, as we progress, we'll show you how to get data from a database, right? You'll do a lookup for some database, right, and retrieve it and whatnot. And we'll see that instead of getting one user, maybe you can get a whole bunch of users or a list of users. Okay. All right. So that's another demo. So we can see Git Status, Git Diff, and you look at it. It says yes, that's exactly what I want. I'm going to commit that. You've tested it. Now we're testing it manually, right? As we progress through the semester, we're going to add automatic testing, right? So that if this behaved correctly at some point, we want it to stay working forever, right? So that it can notify us, hey, you broke something that used to work. What happened? Right now we're doing it manually. We want to automate that a little later. All right, we'll do that a little later. So we're going to commit and we're going to say -am and added get username. Git status, git push. Let's see if it. Okay, looks like it worked. All right, awesome. So it created a branch in my remote repository which wasn't working earlier. We would have to push all the other branches too, which we didn't do. So let's do that. So let's go back to master. We can push master. Okay, how about what other branch did we have? I think we had another branch, right? We have the landing page branch, which we never pushed. So let's go. I'm sorry?
You never actually switched to master to push it.
Oh, I'm sorry. Git checkout master. Git branch. Am I in master now? Okay. Git push. So let's push master. And the other branch, right? So we say git checkout landing page. So git push. So we're going to push also the landing page. So if we go back to the repository, which was failing earlier. Okay, finally. You'll notice that there's a couple branches, right? All the branches that we had created. And that master notice that master doesn't have the controller, doesn't have the models, doesn't have anything, right? It just has the single file that it got created. Yes? All the other work, so, where's all the other work that we've been doing? They have been split up into multiple branches, right? And some of the work lives on the hello controller, which has all the other stuff, right? It has the controllers, right? It's got the models for the user and the hello object. But notice that under main, there's no web app. Where's my index file, right? So we know that actually lives in another branch, right? It lives on the landing page branch. That under source, indeed, there is a web app that has the index file, right? But it does not have everything else, right? It doesn't have the controller. It doesn't have the models. At some point, everything has to be put back into the master branch, yes? So you will be asked in the next assignment, you'll be asked to create pull requests, right? At first, you'll be asked to do it with a TA, right? Because there's no teams just yet. Right? But the week after that, you're going to start doing this amongst yourselves, right? Where one of you is going to be working on one feature, and somebody else is going to be working on some other feature, right? And you need to collaborate, right? And it's a no-no to work on the master branch. If you work on the master branch, you'll be penalized, right? The part of the assignment is that the TAs are going to come and look at your history of your commits. And they're going to look for these things. Did you ever actually commit directly to the master branch? If you have, you'll be penalized, right? So you have to make sure that you always work on a feature branch. You create a pull request. So you go, for instance, you were working on the landing page. You do a compare, and this was your landing page, and you says maybe your commit is enough, right? Added index.html. My really cool. You're going to associate somebody to one of your collaborators, right? I don't have any collaborators. No, I don't have any collaborators. So you're going to assign it to somebody to review. And you're going to create the pull request. You create the pull request, and the pull request generates a URL. You're going to copy that, and you're either going to text your significant other, somebody in your team, and they're going to come. You're going to click on that URL, and they're going to come to this page, and they're going to look at what you did. You're going to look at all the files you changed. They're going to say, oh, they might comment and say, why didn't you do this, that, or the other? Why don't you do it this other way, right? And they can comment and say good things about it, bad things about it. Don't take it personally. It's everybody else's code. You're asking this other fellow to take responsibility for this code. That's what you're asking. You're saying, are you willing to debug this if this is wrong? right? If tomorrow you had to debug this, is it okay? And if they say, yep, I'm good. What they're going to do is that they're going to merge this. They're going to merge the pull request and say confirm merge. And that's what the TAs are going to do, right? They're going to merge it for you. They're not going to actually comment. They're not going to comment on 84 students, right? They're going to blindly merge it for you, right? So you better actually ask for something that works. So that's merge. Very good. Same thing for the other branch. The hello controller branch. You're going to create. You want to merge it into master. You're asking to create a request from the hello control to the master. Before you create the request, you look at all your comments. You look at all the files that you're asking to merge. You're looking at this. Okay, yeah, I wrote that. Yeah, that makes sense. Yeah, that's my hello object file. That's my user. Very good. Yeah, those are my 4 files. Yeah, I'm good. I want to ask someone to look at it. You look at your comments. You're happy. You create your request. You assign it to somebody, and you say added hello controller, and you say create the pull request. And there is my pull number 2, and you send it to someone else in your team. They're going to come here, and they're going to review your code, right? And it says, okay, I agree, but very good. And if they like it, they're going to merge, or they might leave a comment, right? The comment might say, why don't you rename this function name to something else? Why don't you change this variable to something else? You're missing your tests. I tried your tests and they don't work. They don't pass, right? So they'll get into a conversation with you again to increase the quality of the source code. Once they're happy, they're going to merge. They're going to confirm the merge, and now it's merged. Okay, it says it's merged. That means that if you got a master. What's in master? Compare master. Merge. Oh, okay. We're going to merge the pull request. So just merging. Create pull request. This is more towards the end of the week, where you're ready to deploy to a QA environment, or you're going to ready to production. And usually this is a team lead or some manager is going to look at this and going to look at all the various things that have been merged over the week, right, and then decide to finally merge into master. Pull request, and we're going to merge this. So it's been merged, and now if we go back to master, we'll notice that everything is in there. The controller is there, which used to not be in the master branch. The web app directory is there. So now the remote is up to date. Yes, but you locally are behind, right? Because I don't have, because you were working on the landing page and you were working on the controller, right? Each one was working in their own feature. Every time there's a merge, you have to make sure, at least every morning when you come in, make sure to do a pull so that you have the very latest. Right? So for instance, we would come here in the master. Before we get going that day in the branch, let's see, we're git checkout master, we're going to say git pull. And git pull is going to bring everything that I did not have. Right? I was missing that index page. I was missing those controllers. I was missing those models. Now I'm up to date locally. Yes, right? And that's what would happen, during the week, during the day, as everybody keeping up to date with whatever everybody else is doing. Make sense? All right. All right. All right. So that's a presentation on what for the assignment and the use of Git.